Welcome to the Explainer. We're about to unlock this really cool mathematical secret, the one behind pretty much all balance, pattern, and design you see out there.
I mean, think about it. From a butterfly's wings to a giant skyscraper, you see perfect balance everywhere. So what's the big idea, mathematically speaking, that makes it all possible? Well, the secret is this really powerful, but actually pretty simple, concept called symmetry. And trust me, by the end of this, you're going to be spotting it everywhere, like a total pro.
Okay, so let's just dive right in. We're going to start with the first type of symmetry you probably ever noticed, maybe even way back when you were a kid doing arts and crafts. We're talking about line symmetry.
So what exactly is line symmetry? Well, it's pretty straightforward. A shape has line symmetry if you can draw a line right through it, a line that divides it into two halves that are perfect, and I mean perfect, mirror images of each other. That line, we call it a line of symmetry. And the easiest way to figure this out is with what I like to call the mirror test. It's super simple. You just imagine folding the shape along that line you drew. If the two halves match up perfectly, no bit sticking out, no overlap, then boom, you found a line of symmetry.
Now, this is where it starts to get really interesting. Shapes can have more than just one line of symmetry. Take an isosceles triangle. It's got just one, right down the middle. A rectangle? It has two, one going horizontally and one vertically. But an equilateral triangle, where all the sides are equal, that one has three. And the square, wow, the square is the champion here with four. You can fold it horizontally, vertically, and on both diagonals.
All right, so we've got the whole folding thing down. Let's build on that and look at a totally different kind of balance. We're going to move from folding to spinning. This is where we get into rotational symmetry. So what's that? A shape has rotational symmetry if you can spin it around its center point, and it looks exactly the same at some point before it makes a full 360-degree turn. It's like it clicks back into place.
And to measure this, we have a special term. It's called the order of rotational symmetry. It sounds fancy, but all it really is the number of times a shape fits perfectly onto itself during one full 360-degree spin.
Let's actually put this to the test. We're going to use this regular hexagon right here to figure out its order of rotational symmetry. So we're going to spin it around its center and just count every single time it fits perfectly back into its own outline. Ready?
Okay, let's spin it and count. There's 1, there's 2, 3, 4, 5, and 6. 6 times it looked identical before it got all the way back around to the start. Pretty cool, right?
And there you have it. The regular hexagon has an order of rotational symmetry of 6. It's as simple as that. Okay, but here's a quick but really important point. What about a shape that, well, doesn't seem to have any rotational symmetry? Here's the thing. Technically, every shape has it. Because you can always turn any shape a full 360 degrees and it'll look like itself again, right? So if that's the only time it looks the same, we just say it has a rotational symmetry of order 1.
All right, so we've covered line symmetry, the mirror test, and rotational symmetry, the spin test. Now, let's bring these two big ideas together and check out the complete symmetry profile for some of our favorite shapes.
This is basically your ultimate cheat sheet for symmetry all-stars. And check out this amazing pattern for regular shapes. The ones with all equal sides and angles, like the equilateral triangle, the square, and the hexagon. Their number of sides is the magic number. It tells you both the lines of symmetry and the order of rotational symmetry. So a hexagon has 6 sides, 6 lines, and an order of 6. A square has 4 sides, 4 lines, order of 4. See? But look at the rectangle. It's the odd one out here. Why? Because it's not a regular polygon. That's why it only has 2 lines of symmetry and an order of 2.
So you might be thinking, okay, this is neat, but why does it matter outside of a math test? Well, here's the payoff. Because once you really get symmetry, you start seeing it absolutely everywhere. It's like a fundamental building block of our entire world.
Seriously. You'll spot it in nature, like the incredible rotational symmetry of a snowflake or the line symmetry in a flower's petals. You'll see it in art and design, in company logos, in huge buildings. It's even there in science, in the structure of molecules and crystals. It's really the hidden language of balance and harmony in the universe.
Okay, so to wrap things up, I've got a little challenge for you. It's your turn to put on your mathematician hat and apply everything we've just talked about.
So take a good look at this shape. What do you think? Does it have any line symmetry? Is there any line you could draw where you could fold it perfectly in half? And what about rotational symmetry? If you were to spin it around its center, would it have an order that's greater than 1? I'll leave you to think about that one.